so Ali, I think we can start this would be the audience which we have.
Hi everyone.
Hi.
Hi. Okay. What we will be doing today is we will be talking about something which is it's called cognitive science and or rather cognitive computing. Okay. So I want to welcome each of you. Okay, to join in this tech talk. So we would be talking about cognitive computing. Okay. But before we talk about cognitive computing, okay, which is I would say a subject that has condensed from philosophical thinking into computer to language right now. We want to examine it inside out. Okay. So let us begin by understanding what do we want. Okay. And so what do we want? Okay, and how do we approach it? This is rather a philosophical question. Okay, and it is there's no simple answer to this. Okay, so this is somebody wants food. Okay, so these are the things that people want. Okay, he wants to fly. Okay, Dalai Lama says something. Human beings, all we want is to be happy and free from misery. Okay, so this is the person, Bruce Lee. He wants himself to be just called being human. Okay. The slide is with you guys. You can actually go through these codes. Okay, but the point over here is that what we want entirely depends upon who we are. Okay, who we are or what we think about ourselves. Okay, a hungry person would want food. Okay, definitely. We want hike. So depends who we are. How do we identify ourselves? Okay, our desire here is manufactured. So there would be n number of desires. Okay, in the world, n number of desires in the world. Okay, in the world space. Okay. So all these desires, okay, combine in a net of web, okay, that creates a situation. Your desire, my desire, Suresh desire, Manoj's desire, okay, and all the people over here on the call would make a consortium of desire, okay, and that desire, we would call it as a situation, okay, and when there's a situation, there has to be a responsibility. Responsibility means an ability to respond to the situation, a response to the environment. Okay, so now there's a challenge over here. Okay, the challenge over here is that one's desire conflict with the other. Okay, so we would agree that there are so many problems in the world. Okay, and if we go ahead and try to solve one problem, okay, it conflicts with the other. Okay, for example, so if we try to do a lot of development, okay, sort of lot of development in the materialistic world, okay, it's going to create a problem of environment. Okay, if we do a lot of ethnic work, say kind of, okay, it might create a kind of a problem for the freedom of people, okay, or the freedom of choices. If we try to fill up the gap between rich and poor, okay, these are some of the problems of the world, okay, by future survey, by Michael Marion, okay, who is the Future Survey is a the very popular magazine and quite a reputed magazine. Okay, so it's the survey. But you would see in this particular globe that if we try to solve one problem, okay, then there is another problem, okay, which gets affected by the solution that we provide to one problem. For example, an organization is trying to do a lot of automation. Okay, it is encountering with the problem of job shifting. Okay, so there won't be any solution. Okay, without causing another problem. Okay, that's the problem. Okay, that's the problem. Okay, but what could be a solution to this particular thing? Okay, that is what we would discuss. Okay, we call this whole thing, okay, as multi-objective optimization. Okay, now this is a kind of thing that our managers do, the organization do, we do at home. Okay, in so that we actually cater to all the areas of the problem, try to solve the problem, okay, without kind of making any problem inferior, okay, and any problem superior. Okay, so this is called multi-objective optimization. Okay, uh, so this multi-objective optimization, okay, can be called as a multi-objective theory. Okay, and the multi-objective theory says that you might need to formulate problem with one or more than one objective, since single objective with single constraint may not adequately represent the problem being faced. So there is a vector of objects. Okay, which if I put it into simple words, that no problem, okay, can have a unique solution. Okay, so no problem would have a unique solution. So there would be different solutions, okay, for different facets of the problem, okay, which makes one big problem. Okay, so this formula now where f1 is the function for one problem, f2 is the function for the other problem, and so on and so forth. Okay, so fx is a finite number of problems that we are facing. So if we see over here on this formula, okay, we would find that we are trying to make all the problems, okay, as an important problem without giving a inferior space to any of the problem. Okay, which means that we are trying to solve all the problems. Okay, but there is no one solution that applies to all the problems. Okay, so note that because fx is a vector, if any of the component of fx are competing, there is no unique solution to the problem. Instead, there is a concept of non-inferiority, also called Pareto optimal in sensor. So, and it must be used to characterize the objective. Okay. Non-inferior solution is one in which an important all the facets of the problem are taken into account. I would talk about omega, and I'm tempting to talk about the GI, but I would not go ahead and actually discuss it more on the mathematical ground for now. Okay. However, we have understood that a multi-objective theory is a theory of something which is called trade-off. Okay. The trade-off would mean I give something, you give something. Okay. And the relative importance of these objectives is not generally known until the system's best capabilities are determined and the trade-off between the objective are fully understood. As the number of objectives increases, the trade-offs are likely to become more complex and less easily quantified. Okay, the designer must rely on his or her intuition and ability to express the preference throughout the optimization cycle. Okay, what I'm saying over here is that multi-objective theory, okay, would require information from different facets of knowledge. Okay, so the multi-objective theory establishes 4 points over here. Okay, there is no solution, no unique solution to the problem. There is no action that does not influence more than one subject, and there is a need for understanding the cost of action from other subjects. There is no closed system and no closed decision. Okay, this is what it says. It implies to say that we have to know different areas, okay, of knowledge. It implies to say we have to know different areas of knowledge. Okay, in order to solve even a single on the slightest of the problem that we are facing. Okay, for example, okay, I am talking to you. Okay, this is a statement, but with this particular statement, there are a lot of underlying activities that are taking place. There is a social activity, there is an academic activity, there is a managerial activity, and all the things that are happening, okay, they are in a harmony right now, and that is the reason why I am able to stand and deliver a kind of talk to you. Okay, thanks to Suresh. Okay, so now here we are. Okay, in the so we desperately wanted, okay, our system, our thinking to be cognitive, which means it should cater to multiple facets of knowledge, multiple areas of knowledge, multiple domains of knowledge, and the different domains of knowledge, okay, which come together, okay, is called cognitive science. Okay, so one characteristic of cognitive science, we have said that it would cater to multiple knowledge. So what are the knowledge that cognitive science actually talks about? One knowledge is psychology, cognition. Okay, what does cognition mean? Cognition means thinking. Okay, how we think. Okay, it's cognition. Okay, cognitive science is not cognitive computing, but we'll arrive over there in another 5 minutes or 5 or 7 minutes if the time allows me. Okay, so there are different areas, okay, or that are required for a particular decision to take place. Okay, and cognitive science combines all of it together. Okay, one is psychology, the other is philosophy, the other is linguistics, the one is anthropology, neuroscience, and artificial intelligence. Okay, now what is so important is I just wanted to kind of very briefly define, give a unjustified definition for the words that are there. Linguistics is the science of language. Anthropology is how human society grow. Okay, how human society, what is the relevance of knowledge, and it's actually a record of the human development of the human society, and is studied. The evolution of the human society is studied in the context of the present. Okay, neuroscience is how human body, okay, respond to different environment, and what happens in our reflection of thoughts, and how we kind of adjust. Artificial intelligence is a kind of a mimic of those entire activity, and we try to crystallize it into artificial intelligence. So one characteristic of this is it has to be multifaceted, and mind you that these are not just few of the areas where cognitive science is interested in. Cognitive science is interested in genetics. Cognitive science is interested in biology. Cognitive science is interested in astrophysics. Cognitive science is interested in any and every inquiry of through through which humans interact. Okay, so cognitive science, okay, until now that we have understood, cognitive science is an interdisciplinary scientific study of mind and its processes. It examines the nature, to the task, and the function of cognition. Okay, let me take you to a brief history of cognitive science. Okay, what is the relationship between cognitive science and artificial intelligence and computers? Okay, the answer is artificial intelligence. Okay, we are not putting a bet on it. Okay, so that's the answer. So, in short, okay, the history of the cognitive science started in 1950, and I mean the crystallized history, but it dates back to even to the prehistoric era where we had Plato, Aristotle. Okay, these people were there. However, when Descartes came in and David Hume and Immanuel Kant and Bernard Shaw and Nicholas and Perry Cannabis and John Locke have come and created a science of those thinking. They called it, they constructed or gave the foundation to something which is called crystallized psychology or philosophy. Okay. Then came the era of 1930 and 1940, where the famous names were Warner, Macaulay, Walter Pitts. Okay, and these were some of the names that were running. Okay, then came 1970, where the prominent names were J.C.R. Lindker and then Massachusetts University, MIT, actually stepped in and tried to create some of the cognitive programs. Okay, and they were simple cognitive programs. Okay, they were trying to mimic the way the brain works. Okay, in very short history, one of the major contribution of AI and cognitive science to psychology has been the information processing model of human thinking, in which the metaphor of brain as computer is taken quite literally. And this is a very beautiful line. Okay, the metaphor of brain as computer, it was taken quite literally. Okay, earlier, okay, before computer came or were knocked into existence. Okay, the brain was considered to be like a wheel. Okay, but when computer came, okay, then everybody was trying to say the computer has got a brain. Okay, that was the metaphor that was used, and this metaphor, okay, this metaphoric thinking has actually led to something which is called cognitive computing. Okay, so earlier, okay, in the cognitive computing, the areas that actually it caters to, I have switched from cognitive science to cognitive computing in my course of discussion right now. Please see this. Okay, so earlier AI, okay, was based on attention. Okay, I'll talk about attention. There was a very famous experiment that was done on attention, where the person was put to a microphone, and one of the ear of microphone there was somebody was speaking, on the other someone else was speaking, and he was asked to concentrate on one of it, okay, and not to concentrate on the other. After this has happened for 10-15 minutes, okay, the person was asked, okay, to say what the left was saying, okay, on which he was asked to concentrate. He was able to tell you what left was saying, but when he was asked to concentrate, ask the questions about what right was saying, he was not able to answer because he was not concentrating. So attention means, okay, there would be so many noises, there were so many things that would happen around you, but your your AI, your cognitive computing should focus on one simple thing, okay, on one thing, okay, and ignore the other. That's called attention, okay. Knowledge and processing of language, okay. The desire of a human being to talk to the computer in their own language has stemmed something in 1975, and we have reached to a kind of a level where with a little bit of practice, okay, we are able to minimize this gap to around 4 to 5%, okay, which is in itself a very big achievement, okay. Learning and development, okay, memory, perception and action, okay. Perception and action, which means earlier as well there were attempts of recognizing photographs, okay, images, okay. So the computer is able to recognize. These were some of the burning desires that the earlier AIs always had. Okay, but they were not able to achieve it. I'll tell you why they were not able to achieve it. Okay. Now we are talking about computational modeling. Okay, and neurobiological modeling. Okay, so these are the things that actually combined with the first approach that we had, which said we have to see the multi-objective, multifaceted, okay, and then computational modeling and neurological models have also come into picture. So here I have established the point that the cognitive computing mimics the functioning of the human brain. Okay, it is self-learning and responds to change in self-adjustment, flexible and elastic. It is interdisciplinary and performing a multi-objective optimization. So these are the three things that we have just discussed in our course of discussion. That these are the things that have gathered with the computation. Okay, but what we have not discussed? Okay, in the previous examples were dark energy. Okay, what is a dark energy? Are we talking about mafias? Okay, what is a dark energy? Okay, I'll talk about it. No, we are not. Okay, dark energy are the energy that is there in the environment. Okay, not in the environment, in the space. Okay, which is responsible for phenomena like gravitation. Okay, like light, like bending of light. Okay, and there are so many other phenomena which are there. They're happening because of dark energy, and we are only able to explore a 4.9 of that energy. Okay, now this is a physics thing. Okay, that dark energy. Okay, just a few days ago we had it in the newspaper that scientists have discovered dark energy, and the gravitational wave. Okay, and these gravitational wave was a hypothesis of Einstein. Okay, way before something around 80 years ago. Okay, 80 or 90 years ago. However, we are recognizing it through our gadgetry systems. We dig deep into Earth, okay, to minimize or kind of get the minimum of the interference with dark energy. Okay, however, to be able to calculate the dark energy and to make our devices so sensitive. So what I'm trying to say over here is that our devices, okay, our computers, okay, are not so sensitive for the dark energy, but these energy do exist. Okay, in the same fashion, okay, there's something which is called dark data. Okay, dark data. Okay, now this dark energy is responsible for friction. This dark energy is responsible for us us making for decisions. Okay, on the physical world. Okay, so all the decisions that we make. Okay, we think are running in these in the spec of 4.9 percent, but it is often influenced by what is left, 98% of the energy that is in the space. Okay. Similarly, there's something which is called dark data. Okay. There's dark data on internet. What is dark data? The dark data on internet are data that which we are not able to comprehend on the internet. Okay. Or the data which we think are not useful for us. Okay. Over the internet. For example, um, there are so many formats running on the internet. We are not able to comprehend. There are so many pictures on internet we are not able to comprehend. There are so many files. Okay. On the internet which we are not able to comprehend. Okay. If I happen to define dark data, the organization gather huge volume of data which they believe will help improve the product and the service. For example, the company may collect data on how the user use its product, internal statistics about software development process, and the website visits. However, a large portion of this collected data never even analyzed. According to IDC, 90% of the unstructured data are never analyzed. Such data is known as dark data. According to Garner, the dark data is the information asset of the organization collected over the process and stored and are stored during the regular business activity, but generally fails to use the purpose. Now, what are we talking? What are you talking? Okay. So here's the dark data analysis of the dark data. The customer information. Okay. Customer information. Don't we use it? No. There's so many other information of the customer that we take in. Okay. We don't use it. Okay. For activity. Log files. Okay. In the world of IoT, every devices. Is sending signals. Okay. Through its sensor. So, and there is a very minuscule portion of those signals that are being analyzed, because we consider those signals as noise. Okay, noise. You know, one of the IBM researchers have said that the reason for us not to comprehend the problems of the world is because we do not know the problems of the world. We just know only the 5% of the problem of the world, which means that the reasons for which those problems are created. Okay, the dark data out of which those problems are created are not known. For example, okay, we think of using petrol engine, okay, or a diesel engine. They all run on the Carnot engine. The efficiency of the Carnot engine is normally 40%. Okay, 40%, and that's not the normal capacity. That's the maximum capacity in the lab. Okay, the Carnot engine runs at 40%. Okay, where does the 60% go? If you study your textbooks properly in your 12th and graduation, you would say that the 60% of it goes to friction. Okay, friction or enthalpy. Okay, now friction is a very superficial word. Okay, friction happens when two bodies rub on each other. Okay, but is this rubbing of the body on each other is all that friction is about? It's the friction goes deeper than that. Okay, it goes to the molecular level. Okay, from the physical level to the molecular level, but we do not know anything about it. Okay, and that's the dark data. So the pollution of the atmosphere. So we do not know how the pollution is happening. We know this. We just know this is the process that the pollution is happening. But there is a lot of data data behind it, and there's a lot of data after it. Okay, so there's a lot of dark data in the real realms of physics as well. Okay, and if there is, or if there will, okay, any system which can comprehend those dark data, now we would be in better position of not doing the pollution, even revitalizing the environment, revitalizing our rivers, recharging our groundwater resources. Okay, and so forth things. Okay, so there is a lot of data that's missing. The lack of understanding of the activity that we are doing is actually resulting into pollution. Okay, if I put it in simple ways, so there's dark data. Okay, so previous information, okay, is one of the raw data survey, financial statement, email correspondence, account information, note presentation, old version of relevant document, and these are some of the things which I just wanted to actually put into slide, but this list is a infinite list. Okay, there is so much of information that we do not use, but we generate it. Okay, logs coming out of a router, we do not use it. Logs coming out of our laptops, we do not use it. There's so much of information that's there. Okay, and we don't use it. Okay, the temperature in the room. Okay, the temperature in the room, and the speed of my the speed of my lecturers. Say what should I say? Say my eye movement, my hand coordination, your hand movement, your eye coordination, your attention. Okay, if all these things are summed up, okay, it's going to create into kind of a trillion gigabyte of data in just one moment of time. Okay, so there's a lot of dark data that is available in the physical world. Okay, and then if those dark data are tapped, okay, they kind of get accumulated in the internet world. Okay, so if there were if there were a system, that could that could take the advantage of the dark data, if it could analyze those dark data, okay, or it moves towards analyzing those dark data, that would be very, very important, because these dark data are the reasons for us not to take the right decisions. Okay, because these dark data hide or influence the decisions that we take. Okay, for example, okay, making oil and well industry. Okay, we need to dig. Okay, under the earth. Okay, and we do not know whether there would be oil or not. So there's the $1 billion stake over there. Okay, seismology. Okay, which is the science of understanding the vibration of the earth. Okay, which if it exceeds a certain level, we call it a tremor, and if it exceeds a certain level, a notch higher than that, we call it an earthquake. So there are a lot of signals that are there. Okay, and there are sensors. Okay, which are capturing. We do not have the technology to know it. Why don't we have the technology to know it? The question about it is that our computers, until now have been point-centric. Okay, like for example, if I want to translate whatever I am saying in any other language other than any other language like Hindi, Urdu, Farsi, Gujarati, whatever, training. Okay. So it's going to do the translation very literally. Okay, or rather, it was going to take the translation very literally. Okay, but when I'm saying it, okay, okay, there is a certain way that I say it. Okay, there's a certain intonation that happens. There's a certain rate of speech that takes place. There is certain idioms that actually comes into picture. There's some phrases, okay, which when taken literally would mean something else. Okay, but when put in a context, it would mean something else. Okay, those things were not taken into consideration because we did not have that kind of a knowledge of the information. Okay, and that is the reason. Okay, we require, and that's the reason we require opening up our horizon. Okay, so opening up our horizon would mean going interdisciplinary. Okay, so the points that we have established right now is that we required, okay, a computer science that mimics the functioning of human brain. It is self-learning, response to change, and it's self-learning, response to change, and self-adjusting and flexible and elastic. It has to be interdisciplinary in performing multi-objective optimization, and it understands dark data. Now the point 1, 2, 3, 4, okay, where was something that was kind of thought over, contemplated, okay, in the old AIs, okay, but they were not so successful, okay. They were not so successful. What is the decisive factor for these new AIs to be so effective, so precise? Okay, going to the level of something around 5% or 3% of error. Okay, which even the best of us do. Okay, what is that? Okay, it is understanding of the dark data. Okay, they are able to understand a lot of log data. Okay, so what we are seeing right now is the blueprint of cognitive science. What is the principle of its working, and how can it be sure of its answer? Okay. Okay. If any of you are, I hope most of you must have heard of something which is called Watson. Okay. Watson is an API that is run by IBM. Okay. It takes the data from Bluemix Cloud. Okay. And then it analyzes the data and blah 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 blah. Okay. 5 years ago, okay, Watson came up in the news. Okay. It has beaten two of the very best, okay, Jeopardy players. Okay, what is a Jeopardy player? Jeopardy players are the quiz masters. Okay, so two of the very great quiz masters. I don't remember the name of those people. Okay, you can actually put it in Google and actually find it while I talk. Okay, so there he has the Watson has been able to kind of beat them by a very slight margin. Okay, but it has been able to do it. Okay, it was able to understand the speech of the quiz master and then was able to respond. Okay, and then was able to answer the questions. Okay, and was sure of its answers, and then it said the answers. Okay, which is very, very kind of strange. How do we do this? How do we answer the questions? We search it on memory. We are sure whether the answer is right or wrong, and then we say it. Okay, this is how we do it. Okay, but if the computer was to do it, how would it do it? Okay, so say for example, if I were a computer and I am asked to a certain question, okay, and then I would just look into Google, okay, then I will get 50, 60, or 100 answers, okay, and how would I know? How would I know this answer is right? Okay, how would I know this answer is right? Because as a as a kind of a human being, okay, I'm sure that this answer was right because either I have read it from a source which I believed it was right. The word is believe. Okay. And so I believed it was right. Okay. Or I was given this answer by one of my teacher. Okay. Whom I trusted could never ever be wrong. Okay. So these answers, have to be right. Okay. How did the computer believe that it was right? Okay, that's the question. Okay. So the answer to this is the first thing it did was okay that it searched the answers, the questions in its own database. Okay. Its own database means its own indexes on the internet. Okay. So the information are there on the internet. Okay. There's the trillion, I don't know how much data is there on the internet. Okay. So it indexes those information. Okay. And then it it kind of propounded a kind of a theory, not a theory, but statistic. Okay. Giving the weightage to the answers that it was getting. Okay. Based on the frequency of the answers it has met. After it has done this, okay, it ran a search in itself with the answers, is looking for one weighted average, the second the evidences of that answer, okay, which means proofs of those answers, okay, and then it came to then it came and arrived at the answer, so that scope, okay. This is a very difficult thing, okay. Okay, do you understand how much of energy could get consumed, okay, while you do this, okay. Okay, to do this, okay, it is estimated that you would consume energy equivalent to a city, okay, for just doing this, okay, and so how, so they have to, this has to be put on, this computer, which could run to a size of a gigantic building. Okay, cannot be taken to everywhere. This has to be put on cloud. Okay. So Watson was there on cloud. For 5 years, the Watson was there on cloud, and it has improved so much. Okay, right now that it is becoming the best buddy to advocate, best buddy to scientists, best buddy to astrophysicists, best buddy to market researchers, education, transport. We'll talk about it in a moment. I think we have time. Okay, so we can go ahead and talk. Okay, so the cognitive computing forecast to be $2 trillion market in the next decade. Okay, and the decade, this information, okay, of next decade is 6 years old. Okay, so the cognitive computing, okay, has a capacity of understanding image and speech recognition. Deep understanding of text. Okay, deep understanding of text would mean reading between the lines of the text, emotion detection and expression. Okay, translation tool and relation extraction. Okay, relation extraction is a new kind of word, which means that I would say I am not happy. Okay, and I'm going to office. Okay, so it would mean that I am looking for a new job. Okay, so somewhat like this. Okay, so oil industry with the bets are high. Okay, oil industry is right now a $3 trillion. Hello,
Yes, I'm able to
hello.
hear you.
Am I audible?
Yes,
Hello.
sir.
Okay, just a moment. I don't know what happened. Okay, so is the screen visible right now?
There is a black patch, and yes, it's visible now.
Okay. So all industry, healthcare is healthcare. Oh my God. Okay. Healthcare. Yeah, Watson and the new cognitive sciences are coming as a boon to it. Okay. Now a person goes to a hospital and he's suffering from cancer. Okay. Who is this? Just a minute. Okay. So a person goes to a doctor and he is diagnosed of a cancer. And the doctor is an oncologist. Okay. Now, Mohammed, are you working on the incident? Why would I be working on this wrong chat? Okay. Sorry about that. So my story is like a person goes to an oncologist and then the oncologist diagnosed him to be a cancer. Okay. Now there's a treatment that needs to be given to the cancer patient. Okay. It is decided upon his gender, his age, okay, his financials, okay, and a number of factors. Now these are some of the factors that we actually comprehend, but there are factors. Okay, if you take this, if the patient goes to a cognitive empowered center, what it would do is that it would make a complete sketch of the person out of his genetic structure. Okay, and they also have a library and a thesaurus of the medicines that would work for these kind of helical structures of human existence called. Hello, am I audible now? Hello.
Yes, sir.
Okay. So based upon a lot of parameters, okay, which are not in capacity of an ordinary oncologist, okay, to consider that the cognitive science is able to identify the way the patient could be treated, okay, and because what Watson and what these cognitive science kind of people, okay, honest people, they call themselves as facilitators, okay. They don't even call themselves a facilitator. I'm forgetting the word. Anyway, right now, what these AI thing does is, they curate these information into the database, okay, and not only that, okay, they curate all the journals and all the researches, okay, into the database, along with, okay, the other aspects that intersect with that particular aspect of that subject, like medicine. I would always go with finance. Would always also go with the culture, and in Japan, okay, they do not go for open heart surgery because they consider that if you open the heart of a person, the person dies. Okay, the spirit goes away. So the angioplasty and and the other type of angioplasties have actually formatted from there. But the point over here is that there's a cultural barrier to the way the medicines are actually propagated. Okay, so it would consider everything before prescribing you what needs to be done. This is the thing that is coming. Okay. Astronomy, market research. Market research would tell you what are the products that you love to buy. How do you think? What is that particular product would be? What would be the liking of the product? Education. It would come like it's coming like a boon to education. It's actually is able to form the pattern. Okay, is the way you learn. Okay, and what are the subjects that you learn and how you learn those subjects, so that you can leverage that pattern to learning the other subjects. Okay, so transport it is coming big way in transport, in actually deciding the way the transport systems are to be managed. You can get a lot of information in the bibliographic links that I have actually pasted. I'll go through them. There's deep researches, because I'll tell you a small story at the end of this particular session. But here are some of the cognitive computing competitors. Okay, so you can actually go through them. Okay, Spark Cognition, Microsoft Cognitive Science, IBM, Watson, Expert System. Okay, Customer Matrix, Cognitive Scale, DeepMind. Okay, so there's so many competitive, and mind you this. Okay, Watson, because I wrote it in the in my write-up. I was talking about Watson. So Watson is an open source. Okay, and now I'll talk a little bit more about how this cognitive science with Watson works. Okay, because in another 5 minutes I would talk a little precisely on Watson. Okay, so these under hood that you see this part. Okay, this part, this is all knowledge. Okay, that Watson. Okay, these are the knowledge that Watson offers. Okay, it has a system of ingesting the information, how from seeing, from our speeches, from the language. Okay, and there is a digital insight to it. Okay, I mean, digital insight would mean it would take the data from the logs, from the way you type. What you're typing, somewhat like a Cortana, if you're familiar. Okay, and here is the curated kind of knowledge that they have actually assimilated. Okay, and these are not this is not all. Okay, just a diagram that is showing it. Okay, the interesting part over here is that that these are the programs. Okay, these are the systems through which the Watson finds the answer. So if a person wants an information from Watson, okay, he would give a question. Okay, and the Watson API would look for an engagement advisor, then retrieve rank and the concept, insight, NL classifier, trade-off analysis, dialogue, and document conversation. Okay, and then it would look into the corpus. Okay, and then it would give the answer to the system. Okay, and these systems are again the API. So how do you contact Watson? You contact Watson through APIs. Okay, these are programmable interfaces. Okay, and we will talk about these programmable interfaces in a minute right now. So they are basically RESTful programmable interface. They are interoperable. Okay, which means that they are network neutral. Okay, so which means the RESTful API, when you query something through RESTful API. I am a .NET okay, and I am querying to internet. I don't know the information that is there on the internet. I query in .NET and it goes through RESTful API. Okay, wherever it queries, okay, whatever it does, okay, it gives me the answer. It passes the information through the tunnel of RESTful API, and I get the information in neutral formats like JSON or HTML, and I use this JSON or HTML to actually figure out what it has said. This is how it works. So these are some of the things that I think I'm running out of time. 5 minutes. So I thank you all, okay, for being with me, okay, and I open this session for question answer. Guys, if you have any question, please put it on to me. Hello, am I audible?
Yes, Ali. No questions from my side.
Okay, thank you. Anybody, any question over here? Okay. Somebody is typing something. It's like, okay. Now, what I'm trying to say over here is that from 2nd of November, I am starting with